purpose of this video is to create an infographic in R. This infographic will contain 3 visualizations, and the output will be a 2-page report as a PDF document. Before I start, I want to show you this PDF document that I do have saved. This was made in Word and saved as a PDF, and then I just saved it in my R project folder, and it's titled, it's saved as intro.pdf, and this is just a 1-page consultant summary report explaining the background, method, and justification for using an infographic. I'm going to go ahead and close this because I no longer need it. It's just that I'm going to use that later, and I wanted to let it be known that it was already created. So I'm going to start here in my RStudio environment. My plots, and my console are clean. They're empty, and I'm going to talk about my code and then run through my code in little chunks so that I can point out things as I do so. So here, this first function and argument that I am using is to save the default parameters of the way R displays graphics in this area down here in the plot area. It's just let me start over. This par function is the parameter function, and by default it is this no.read-only equals true. And what I'm doing here is saving the default parameters to this object. So that's what this is. I'm going to go ahead and just run it, and you see the default parameters is actually a list of 66 functions, or 66 parameters, I should say. They're not functions, that are involved in the graphical interface down here in they call it the screen, or the plot area. So then the next thing that I'm going to do is I'm going to load my library, or my package readxl, by using the library function. The package is already installed in my R environment and on my computer. I just need to load it so that R has access to it in this session, and I do that with the library function. Next, I am going to import my data for a bar graph, and so I'm going to save my data to this object called bar_data using the push operator and the readxl function, and this just goes to a location on my computer. So I'll just do these at the same time. I run it, and now we have the bar data. For the other 2 visualizations that I'm going to make, I am just going to generate data for these, and so I'm doing it twice, once for a histogram and once for a density chart. So the setSeed function is, so if anybody else wanted to replicate either of these visualizations or the data, they could do so by setting the same seed and using the same parameters as mine. So I'm going to set my seed to the value of 1, 2, 3. I'm going to create an object called HIST_data for histogram data. I'm going to push this function and argument into the histogram data. That's how you make an object. So I'm going to use the function data frame. I want to create a data frame, although really it's just going to be one variable. It is going to be called rating, and the rating variable is equal to a normal distribution, 150 variables, the mean of 7, and the standard deviation of 2.5. And this rounded is just not going to give me any decimal places. And then I'm going to do the same thing for the density plot, but the density plot is a has two variables, and one of them is factored into a low, medium, and high kind of treatment or condition. They represent my trainings. And so to set that one, I'm going to set my seed, use the function set seed to 1, 2, 3, 4. And then I'm going to create an object called density data. This data frame, so this is my function, I'm going to have two variables, the treatment variable and the score variable. The treatment is going to be a factor that is represented by low, medium, and high. Each one is going to have 200 variables, and this C right here is just, means concatenate. It just means that I'm going to combine each of these items into this one. This rep will repeat low, medium, high, the concatenate in each 200 times. So usually the repeat function may have it has two arguments. The first argument is the value that you want repeated, and the second argument being the number of times. So here, the low, medium, and high would be the values that I want repeated, and each of them is going to be 200 times. So that's my treatment variable. My score variable is also rounded, and I'm going to concatenate or just bind these three values together to be all are going to be a normal distribution of 200 each, because they need to be equal group sizes, and the means are going to be a little different. So they're all going to have the same distribution of standard deviation, but their means are going to be slightly different. The first one being 55, the second one being 65, and the third one being 95. So these three distributions are concatenated together. They will be rounded, and they equal my score variable. So I will have a total of 600 data points on both treatment and score. So I'm just going to go ahead and generate those variables. So now I have my density data here. So we have the treatment and the score, and my histogram data, which is some ratings. We've already seen the bar data. Awesome. Okay. So now up here, I talked about saving this default value, and I did that because the next thing that I'm going to do is I'm going to change the layout of the graphics here in this plot area. So I'm going to create an object called HS. I don't remember why I named it that, but I'm sure it was important at the time. And to that object, I am going to alter the layout. So I'm going to do that using the layout function. You see here when I hover over it, it does give me the arguments to this. So I am going to change the layout of the area into a matrix. Specifically, I want to, so I have the matrix has two arguments. I want to have three visualizations in this area, one being all on this left side, and then the other two being stacked on top of each other on the right side. So I want two columns, but I want the right column split in half. So you see the number of columns I have equals 2, and then in a matrix with two columns and one row, or a row for each column, so it's a 2 by 2 matrix. And then I am going to, as a 2 by 2 matrix, and there are 4 positions, 1, 2, 3, 4, and here this concatenate that is binding these values together is indicating where I want those values, those sections to be represented by. So I'm telling it 1, 1, 2, 3, and it's going to label this section on the left as a 1, this one up here is 2, and this one up here is 3. And that is, so that just lays out this is actually wrong information. That lays out 2 rows and 2 columns placed for each graph. So check this out. I'm going to run it, and then I have this HS value, and then so I'm going to use this layout show function so that we can see what it looks like. And then here down in the plot area, it shows that my first graphic, or the one is going here, 2 is up in the right hand corner, 3 is in the bottom right hand corner, and I did that using this concatenate function. And so it is possible to manipulate these layouts in different ways, and of course also make more sections of this. But for my purpose, I just need these 2 rows, 2 columns. But you see, I am combining the 2 rows on the left to just be one big visualization, and I did that by repeating my 1 right here. Okay, so now I'm going to start using my parameters function, and here I'm defining the parameters of this area and its margins. So the margins are going to equal, and that's the amount of space that's going to be on each side of the visualization. Now, it's a numerical vector, and by default it has some values. I didn't include them here, but it goes bottom, left, top, and then right is the order of the concatenate. So the order is important, and this is how many lines that I'm specifying for the visualization to have on each side of the plot. And when I call this argument, this first plot is going to go into number 1 because it's the first plot and the first argument that I am calling. So now I am creating a object called bar, and using the table argument, which is using my bar data right here and the variable training. So, and I'm saving that to bar. And then I'm creating a bar plot using the bar plot argument and the bar plot function. And then let me go over the arguments that are in this. So the first argument is the data or the object, and so I called it bar right here. The width that I'm using is 1, and that's the width of the bars. The main is the title. And of course, each of these is using the equal sign, and each the argument is followed by a comma until I close the argument here. So the X label is going to be training treatments. The Y label is the time to complete task in minutes. And I decided to use the color argument, and I chose deep sky blue. Great. So let's run it and let it do its thing. So you see it put it only here, although I see something wrong with my data with this chart, but I'm just going to keep going and I'll figure it out later. But this is supposed to say hi, I think. No, well, I mean, I know, but I don't know why it's not saying that now. I'm going to just continue on. Hopefully it will show up. So then I'm going to call in the next parameters argument, and this indicates to R that I want to create the second visualization that was going to go up here in the right hand corner. So I'm going to call the parameter function and give it the value of the margins argument will be these 4 values, which are the margins for each side of the visualization that's going to be in the top right. These are intended to give enough space for all of the text that is going to be and labels that is in each of the plots. So I'm going to create a histogram with this histogram argument. The first argument, the histogram function, and the first argument of this function is to indicate what data I want it to use. So I want it to use the histogram data, and the $ means we'll call the specific variable that I want out of the data, and in this instance it's going to be the rating. So here it's actually the only one, but it's the rating. And it's called rating here, but I just because that's what it's called in my data, but I'm going to rename the variable when I get to creating my labels. So using a comma, I'm going to add additional arguments to this function, being the main is the title, the X label is the number of bits made, the Y label is the number of employees, and then so this XLIM changes the the values on the axis. I got stuck there for a second. And then here I went with light blue for the color. So I'm just going to go ahead and run that. And here we have the histogram, the number of bits made, the number of employees, and production rate. Very cool. So let's move on. So the next thing I'm going to do is I'm going to create the density plot. And this one is a little bit more involved, but it's also really kind of fun. And I did mess around with this one for a little bit. So I'm calling the par function again. And the margins that I want, if you see here, they are slightly different than what I used for the top right-hand corner. And that's because down in the bottom corner, if you remember that this value is, the third value is the top, I had to change it so that I could make room for the title so that everything could be seen clearly while they were still the same size. So for this, I'm going to invoke the library SM with the library function so that I can, oops, I forgot to do this. Hopefully it doesn't mess it up. So first I'm going to use this smooth density compare function to compare the three density treatments that I'm using to create this graphic. So the two variables that I'm going to use is the score on the, oh look, it already made it down here. I didn't even see it do that. Did I do it first? Oh my gosh. Well, now it's here, but it's not done. So the density compare function, this is my x-axis, this is my y-axis, and my x label is score. So you see down here, it has already made it, but it didn't put in my title. So I'm just going to like rerun this. Sorry. There's actually more steps to it, but I guess you can do it one by one. I just never actually have. So there's the title. Then next, I'm going to create a legend for this because, you know, I don't know, to the reader, nobody's going to know what these are, the green, blue, and red densities, density plots. So I'm going to create an object called color fill. And this is a real fun chunk of code. And what it does is just creating a vector. And this is pretty interesting. So it's creating a vector of values based on this variable and their levels of the levels of variables. And I change these around. And so they do change the colors, but I don't exactly know how to explain what they do. This vector represents the colors that it will use. And so the 2 semicolon 2 plus length is how you get the colors to match the colors that it automatically puts into this density plot. I played around, both of them will change colors, and I played around with the different colors that it could have and found some really eye-pleasing colors, but they would not match this the density curves here, so I didn't use them, and I just set it back to default, which is this 2 semicolon 2, which I know that this just creates a vector of length of the density data variable. Then the next argument is to create the actual legend. The locator 1 argument, it tells our not to go any further, that the placement will be indicated by where the user clicks on in the graphic area. And then the levels are still going to be the same treatment variable that I specified for the colors, and the fill, which is the color of the indicators of the little squares in the legend, will be this object that I created, color fill. So I'm just going to go ahead and run these, and it gives me my little mouse pointer has changed into this cross, and I am going to click it, and so now it gives me my legend. Pretty cool. Okay. So now what I want to do, now I have my 3 infographics. Now what I want to do is I want to print and save these to a PDF. I can do this in 2 ways. I can use this export and save it as a PDF, or I can just say, hey, dev print, this is a function that will just like save the output into multiple formats. I chose the PDF. The second argument is what I want the PDF to be called. And then the width and the height are how big I want them to show on the paper. And then there's also a paper argument, which just indicates the size of the paper, and there are multiple options. I just chose letter. The default for these is usually 5, but I found it to be a little bit small. And if you make it uneven, then to me it just didn't look right. It looked a little stretched out. So I just made it a little bit bigger on the page. So yeah, I'm going to run that. It has, hold on. So it has now created this infograph file right here. And just to be clear, this is intro PDF is the one that I showed you at the beginning of the video. Now I have the infographic as this. And then before I move on, I am going to call my my object that I made earlier to reset the default of the parameters of all of this. So I'm just going to run that. It reset my defaults to the way, to standard, so that there will be no issues later. And then I'm going to load a new library. It is called QPDF, and I really like it. And it is going to allow me to combine and edit and do other things for PDFs, but I'm just going to use the PDF combine function. My input that I want is going to be 2 arguments because I need it to combine 2 things, so I'm going to use the concatenate again with the intro PDF and the infographic PDF that I just made up here. And the output will be saved to an infographic report, /CT. So let's do that. Run. And then here, now I have my infographic report. I'm going to open it. And now I have page 1 and page 2. And see now, interestingly, here is the high. I didn't notice it on the infographic. But see, I remember in here, it wasn't saying high. So now I have a 2-page infographic report that I combined in R. Lovely. That is all.